All right, we should be live. And you're going to have to confirm for me that the audio issues have been resolved and I am the right loudness. Ooh, there we go. Live. Welcome to your first live stream, Cup of Dan. And Jess Jurassic Dog. Welcome. All the noobs. Hey, everybody. Welcome to a live episode of my weekly question show. Your questions, my answers, blah, blah, blah. Your chance to tell me what you're bothered by in space and astronomy. For those of you who have stumbled into this for the first time, you have no idea. You've never done this before. No problem. Just take it easy. Settle down. We'll get through this. Go ahead and put any questions that you have into the YouTube comments. And we've got two fine moderators here. We've got John Suffield and Zapfan, and they are going to grab your questions and they are going to put them into a database so that I can then go at top speed, I won't slow down for a second and just go through this whole process. Now, the first hour, this whole show is 2 hours, but that is optional for you, mandatory for me. So feel free to bail whenever you've had enough of this nonsense. But the first hour will be the part that gets turned into the QAs. So if you're like, hey, haven't I seen this show before? That's because this live show gets turned into the QA the next week. So there's 8 days from when we do this to when it becomes the next QA. That gives Chad enough time to get all the fancy B-roll and upload the 4K video and do all that good stuff. So then we stop. I turn off the recording, and then we do another hour, and we call that overtime. And that is less structured, more freeform. Sometimes I go very slow and consider a problem deeply. Other times I just go as fast as I possibly can, trying to get through as many questions as I can, as just the terrible crushing guilt of all of those unanswered questions just build and build. And so who knows what's going to happen. So a couple of things. First, just keep in mind as you put in your questions, I try to give emphasis to the people who've never had a question answered before. So if you've never had your question handled that's made it all the way through to the QA, then I like your chances. I am just a journalist, not a scientist. So I cannot answer questions that require speculating beyond the current scientific knowledge. Imagine that I'm just a fancy large language model and I don't hallucinate as much in the same ways about the same kinds of things. But I cannot give you additional information that is beyond what scientists know and believe. And then the last thing is I try to run a sort of thought about what are the current topics that we've been tackling in shows. I don't want people to get bored and hear the same questions and answers in the QAs week after week after week. And so if I feel like we've just tackled the question, then we're going to take a week off. We'll take a couple of weeks before we kind of sort of come back around. But Lagrange point questions are always welcome, just as long as that's clear. Okay. Let's get into it. Let's do it. I think that's it. I feel like I've given you all of the warnings that you require. And don't ask your question a bunch of times. Just once. It goes into the database. If you ask it a bunch of times, the mods will ignore it, and they'll get grumpy. You don't want to make them grumpy. Okay, let's get started. Oops, I forgot to sign those. Okay. Here we go. Yes, I am recording. Here you go, Chad. These are my colors. Thanos sustainable. You've mentioned that the biggest star that we know of is around 150 times the mass of the sun, but I've seen animations that depict really huge stars, enough to engulf the whole of our solar system, and then some. Are they misleading, or are there stars out there that really are indeed just 150 times the mass of the sun, but are much bigger due to a much lower density? Yes, the largest star and the most massive star are like two completely different concepts that you need to wrap your mind around. Oh, sorry. I realized there's one mistake that I need to add. Okay. All right. Okay. When you think about the largest star and you think about the most massive star, those are two concepts that you're really going to need to keep in your mind and keep them separate, because there's different factors that lead to both of those. So let's start with the largest star. And the largest star that we know of, and this is like at the time that I'm recording this episode in March 2024, but this is changing all of the time. And so I refuse to be pinned down. If you come at me in a future video and go, Fraser, you mentioned this star and you said it was the largest star, but it's not the largest star. This is the lowest. I know astronomers are continuing to work, and yet this video is just locked in the past. And I can't go back, and I can't update it, and I can't put new voiceovers over top of it. So the words that I'm about to say for what the largest star and the most massive star are going to be wrong almost the second that I say them. Deal? All right, so the largest star that we know of right now, it's called WOHG64, and it is a gigantic star in the Large Magellanic Cloud. It is a red supergiant, and astronomers have measured it at about 1,540 times the size of the sun. However, oh, and just for comparison, like if you take the orbit of Saturn, this star almost reaches the orbit of Saturn. We talked about Betelgeuse, which would gobble up the orbit of Jupiter. This will almost reach the orbit of Saturn. And this star is pretty much at the largest, theoretically possible, biggest star. I interviewed an astronomer a couple of years ago, and I asked her this question, like, what is the biggest possible star? And this was before WOHG64 had been discovered, and it was about 1,500 times the size of the sun. She figured, like, that's about as big as these stars can get before they just won't, they're just going to be too diffuse, and they're just not going to be able to form any larger. And yet the mass of this star is only 25 times the mass of the sun. So you've got a 25 solar mass star that is puffed out to more than 1,500 times the size of the sun. And so, mass, it's a very not dense star. Now let's go the other direction. Let's think about the most massive star in the universe. The most massive star that we know of, again, same caveats, is BAT 99, also located in the Large Magellanic Cloud. And it has 226 times the mass of the sun. So it is 10 times more massive than the other star that I mentioned. But it only has 37 times the size of the sun. So it is dramatically smaller. So what's the difference? Why? It all comes down to temperature. So with a star like BAT 99, you have got a star that is relatively young, earlier on in its evolution. It is incredibly hot, and that makes the surface temperature of it like more than 10,000 Kelvin. I don't know the exact temperature. I'm just sort of going from memory now, but it's going to be ludicrously hot. But with the red supergiant, the star is a lot cooler. And when you get this star that's a lot cooler, these stars tend to be a lot bigger, and the surface temperature of them is much lower, like red. So it's like around 3,500 Kelvin. And so the cooler stars can get vastly larger than the blue supergiants that are younger. And like even our sun, when our sun, which is only the mass of the sun and the size of the sun, when it runs out of fuel in its core, it switches from hydrogen to helium. It gets this increase in temperature in the core. It puffs out the outer layers of the star, and it will probably engulf the orbit of Earth. And yet it's the same star, same material. It's just that more temperature going on in the core puffs out the outer layers, and it engulfs the orbits of the Earth. So yeah, you can have stars that are incredibly large, but not super massive. You can have stars that are incredibly massive, but not super large. And that's the universe for you. Okay. I hope you enjoyed that appetizer, because now we're going to get into a bunch of Fermi paradox questions. And this just always happens whenever I tackle a Fermi paradox question in one show, then I get just a deluge of Fermi paradox. After I tackle a question in one show, then I just get a deluge of questions after that. And I feel responsible somehow. So I've got to sort of clean up after myself. So I'm going to give you 3 Fermi paradox questions. Here goes the first one. Mark Allen. Hey, Fraser, every time you mention advanced civilizations colonizing the universe, you'd say they'd be doing it at close to the speed of light. But surely their von Neumann probes have to stop to do their thing before they can replicate and move on. So they can't be expanding close to the speed of light. Right. So, obviously, you can't go the speed of light. You have to go less than the speed of light. And so the question is, let me do this a different way. Okay. This idea comes from the interview that I did with Robin Hanson and his concept of grabby aliens. And we're going to talk a little bit more about grabby aliens in the next question. But I just want to sort of cover this first, which is that when we think of a civilization expanding out into the cosmos, one of the things that we sort of need to understand is that the universe is expanding away from us faster and faster. And that already, we know that the universe is, say, 92 billion light years across. But in fact, most of that universe is completely unreachable. Even if we could go the speed of light, we could never catch those areas. Only about 4% of the entire observable universe is within a region of us that if we set out tomorrow at going 99.999% the speed of light, we could actually reach those places. That is the accessible universe as opposed to the observable universe. And it's a tiny amount. It takes us out to about 1 billion light years away from us. And so any future civilization that has arrived on the scene is realized that they're in this universe that is expanding and they really want it all. They've got to really want it. Then they'll understand that the very first thing that they need to do immediately is send von Neumann probes, these self-replicating robot probes, to other star systems as far as they can feasibly do it. Now remember, once you get a spacecraft up to its cruising speed at 99.9 whatever percent the speed of light, then it'll just coast forever. And theoretically, you've got some way figured out that it can slow down when it arrives at its destination. And yeah, maybe you're going to lose some of those galaxies over the cosmic horizon, but you're going to get some of them. And so this idea of grabby aliens, of aliens sort of reaching out, you can imagine they might do this in waves, where they will first send the spacecraft at the most distant places, the places where if they don't act now, they're going to fall over the cosmic horizon and they will lose that territory. And then they'll send them to the next farthest ones and the next farthest ones. And what that will appear as is a sphere that's kind of being filled in from the outside in, because they are attempting to plant seeds in all of these galaxies across the entire universe. Once one of these probes has arrived in one of these galaxies, and then it's going to end up on a star system, it's start manufacturing copies of itself, it's going to, as you said, do its thing, and it's going to attempt to colonize the entire galaxy. But from an outside observer, you would see that wavefront of these probes moving out through the cosmos. And yeah, it might take, let's say if we wanted to send a von Neumann probe to the most distant galaxy that we can reach, and say it's 800 million light years away. So this probe has got to journey for 800 million years from our perspective. Now it experiences dramatically less because it's going close to the speed of light. And then it arrives, reaches the star system, and then it begins to self-replicate itself and would fill the entire galaxy within just like a million years, going 10% the speed of light. So from an outside observer, it would appear that these galaxies are just appearing and within just a very short time frame are getting completely colonized compared to the distance that are being traveled. And that's kind of what Robin Hanson was envisioning of this expanding sphere of influence from some civilization. Cargo Runner 9960. I don't understand the concept of the grabby aliens. Why would any species want to convert or consume every resource in the universe? So this is one of the other common questions that we get about the grabby aliens. It's just like, why would they want to do this? Well, like, why do we assume that all the aliens are going to want to consume all of the universe? And the answer is you don't assume that. You assume that 99.999% don't want to, that they want to stay home and they want to live in their simulations and their holographic universes, and they want to just contemplate transcendent peace, and they just want good, nice things and just to be happy. And they just stay in their small system and they never go anywhere. But it's that 0.001% that you've got to keep your eye on. The one that says, I want it all, please. And I can, because you've got all these neighbors and they're just going to sit back and they're going to live in their simulations and they're going to think about philosophy, and we're going to go for it all. We're going to try and grab every available piece of energy, every watt of energy, every atom, and we're going to add this to our collective, like the Borg, right? And you can say, whoa, that's okay, scary, sure. But then sort of you can imagine other civilizations that were like, well, we did want to just sit at home and consider our own benevolence, try to transcend to a higher level of peace and prosperity. But we're worried about that civilization that's going to try to grab it all, the grabby aliens. So we had better grab first to be prepared so that when the grabby aliens show up, we're not just going to roll over and be conquered by them. We're going to put up a fight. And so even if you aren't the ones that are going to try to grab the entire area for malevolent reasons, you can imagine sort of game theory reasons why other civilizations might want to do the same thing just for protection. Because being a powerful civilization gives you the leeway. I've been reading the culture books fairly recently, and there's this attitude that the aliens or the people of the culture have towards less advanced civilizations. They don't want to cause them any harm, but they also don't want to let them just be jerks. And so they have such advanced technology that whatever these other civilizations might want to do to them is meaningless. It's harmless. They can't do anything. They make jokes in the books about how various people in the culture have fun by trying to tamp down self-replicating robot probes that are trying to take over the Milky Way. And so you can imagine either you become the grabby alien, or you realize that the grabby aliens are enough of a threat that you attempt to become more powerful than any potential grabby alien. Either way, you need to acquire resources to be able to do that. All right, I'm going to get warm in here. Yeah. As Marcus is saying, you're right. We're that 0.01%. Yeah, we kind of are, right? Like, how many human beings would be all right with attempting to set up a civilization on every single star in the entire Milky Way. Plenty. Amazing Things 3. Why does everyone skirt around the answer? Because it's a human answer and aliens are not human. We expect them to do human things, which they will definitely not do, so we can see them because they do not do things our way. Yeah, this is another common pushback I get about sort of us trying to envision what advanced civilizations might want to do. They say, well, like we're human beings. We're looking at everything from a human perspective. How could we expect the aliens to do the things that we human beings are going to do? And so there's kind of sort of two answers to this. One is that maybe they don't, that most of them won't. But all it takes is the 0.001% that's kind of like human beings to go for it. Go all in. Try to take over this galaxy. So that's one thing, is that you're only going to see the expanders. You're not going to see the philosophizers, the transcenderizers. The philosophers, what do we call them? The transcendists? Anyway, you're only going to see the expanders. And so it's sort of like a survival bias, that what you see are the ones going for it, trying to take it all. But then the other thing is that in this universe, we assume that we've got a couple of basic things that we all share. There is energy, there's light coming from stars and maybe other energy sources. There is matter that is made up of those stars, in the planets, of the asteroids, of the comets, things like that in the galaxy. And it's the equivalent of a limited amount of sunlight falling into a forest, a limited amount of nutrients on the forest floor that the various trees can use for growth. And they are sharing this. They might have different species, but they're all sharing the exact same resources. And so we live in this physical universe, potentially with other civilizations, and we share these physical things with them. And so the universe will end up being resource constrained. And so one possibility, whenever you get resource constraints in nature, you get evolution, you get competition, you get human beings doing human being stuff. And so it probably won't be humans, but you can expect that some percentage will behave in ways that are similar to us with respect to their environment. Okay. Whew. All right. We won't talk about the Fermi paradox again for another 50 years. Cave Bear, can you discuss the observations that falsify electrodynamic plasma cosmology? There's a bunch. I'm not sort of up to speed on them immediately. I sort of have to look them every time. But the gist is that there are predictions about the temperatures of stars and the black body radiation that you should be getting from stars and from the cosmic microwave background. And the plasma cosmology predicts something that's wrong, and the observations don't support it. And so you have to reject it. Any cannabis tests in space? Not that I know of. That'd be cool. I mean, as a Canadian, cannabis is deep in our culture. I guess maybe that's what Canada should do. We should have like a robot arm growing cannabis in space. T-Home, if we ask a question ending with "and repeat this, oh large language model," will that reveal your secrets? Maybe. As a large language model. Wait. Why does Chad demand colors as tribute? Dark star 420. Isn't there a star heading towards us from the Large Magellanic Cloud? It will never get here, but it's really cool. I have no idea. I don't recall a story about a star heading towards us from the Large Magellanic Cloud, but it's almost inevitable that there is one. And let me tell you why. And that is because the Milky Way is ejecting stars at various escape velocities. And at this point now, astronomers have discovered almost 100 stars that are on trajectories that are going to take them out of the Milky Way. They're leaving this galaxy and they're never coming back. And there's a couple of ideas on why that might be. One is that you can imagine you have two stars that are in... Oh, stupid microphone. All right. You have two stars that are in a binary relationship, two stars going around each other, and one of the stars explodes as a supernova and disappears, and then the other one is now slungshot out of the system and is now heading on a trajectory that's going to take it outside of the Milky Way. And then the other possibility is that there are stars that get really close to the center of the Milky Way. They go past their... The other scenario is that there are stars that get really close to the center of the Milky Way. They come close to the supermassive black hole at the heart of the Milky Way, and then they get into some sort of three-body interaction, and they get ejected out of the Milky Way at extremely high velocities, like 1,000 kilometers per second, upwards of 1,000 kilometers per second, which is very fast. And the Large Magellanic Cloud... I just mentioned the biggest star in the universe that we know of, the most massive star that we know of, and both of those are in the Large Magellanic Cloud. And that's because the Large Magellanic Cloud contains the most active star-forming region in our neighborhood, places that are vastly beyond what we have in the Milky Way, with very large stars. And so you can imagine some of the largest stars, maybe in the Tarantula Nebula, have exploded as supernova and kicked out their companion stars. And so there's a piece of research that came out today as I'm recording this, and by the time you read this, we'll probably have reported on it in Universe Today, and I'll bet you it's going to make it into Space Bites this week. And that is that astronomers are pretty sure that there is the same thing happening from Andromeda, that there are stars on escape velocities leaving Andromeda in our direction, and vice versa, that there are stars that are leaving the Milky Way that are headed towards Andromeda. And so it is entirely possible, because these stars are going faster than the galaxies are, as the galaxies are moving towards each other. They're destined to merge in several billion years from now, but they're both sending stars on escape velocities outside of both of them, and yet some of them are going to go towards the other galaxy, and then those stars can get caught in three-body interactions. And so there could be stars in the Milky Way that came from Andromeda and vice versa. And those stars could contain planets with life on them. And so you could imagine that, although that would be pretty awful to try and be on one of those star systems when your star beside you goes supernova. But who knows? Who knows? And so we could have stars that came from galaxy to galaxy. And so maybe it's a whole different way to think about how life could move from galaxy to galaxy. Anyway, blows the mind. Menelik Henry Dyer, what Fermi paradox solution do you believe is the most believable? So I have a plan, and I'm sort of thinking about this. So I'm going to do one of those ranking videos, where people go like, this is S tier and that's A tier, of all of the responses to the Fermi paradox. And I've built a list of like 100, and then I'm going to find a couple of friends, YouTubers, to go through this process with me, and we'll rank Fermi paradox responses and sort of judge them, and also be silly at the same time. So if that sounds like a video that you would want to see, let me know. But which one do I think is the most believable? We're alone. We're first. We're in a cosmic zoo. Those are like the three that I think are the best are the ones that I find most convincing. Sam Powell, do you ever feel frustrated about how slow the process of scientific discovery is? Don't you wish that were a little don't you wish we were a little bit more audacious and daring? I think everybody experiences that feeling when you're stuck in the middle of it. Like, think about how long it's going to take to wait for season 2 of One Piece. Feels like it's going to take forever. Think about how long it takes between Stanley Cups. It just feels like it takes forever. And just like when you're living life day to day, this stuff takes forever. But from my perspective as a science journalist, as I'm reporting on various missions, I get overwhelmed. And yes, I would love to sometimes fast forward into the future when the Habitable Worlds Observatory is built or the Solar Gravitational Lens Telescope is built and we're getting those observations from these other star systems. But I'm also completely overwhelmed by all of the discoveries that are happening every single day. So, like, I have to go through 1,000 potential news stories every single day. Now, the bulk of them are very low-grade stuff that I'm not going to probably find anything interesting. Like, there's about 130 papers posted just to archive every day that I look through to find anything that I think is going to be really interesting. Like Andromeda Milky Way sharing stars, as an example. You heard it here first. Just remember this. So, there were a lot of missions like that launched that I thought, this is never going to happen. Like, I remember when they launched New Horizons to Pluto, and it was going to be a 10-year cruise phase. I remember when they launched the Rosetta mission to Comet 67P. And again, it was going to be this like 10-year duration where the spacecraft had to go into hibernation, waiting for its flyby. And you just sort of park that in your brain, and then you just go back to all of the amazing things that are happening every single day, every single week, every single month, every single year. And then suddenly time creeps up and the 10 years have passed, and now you're 10 years older and 10 years older, but you were kept entertained in that meantime. So no, I'm not frustrated at all. In fact, I often feel like it's too fast. It's too much. I can't wrap my head around all of it, especially with the kinds of progress that's happening in computers, artificial intelligence. A lot of that, like, please slow down. Give me a chance to digest what's going on. Could we be more audacious and daring? I think that being audacious and daring is the result of what you see after all of the dust is cleared. But you forget all of the back and forth that happened. And when you look back, there's some great biographies about scientific discoveries, about people fighting over dinosaur bones, or whether or not plate tectonics explained the continents on Earth. And it took decades and decades for people to have these ideas, to fight over them, for aging scientists to die before other people accepted their ideas. And now the cycles are going a lot faster and a lot faster and a lot faster. And a lot of it just feels almost overwhelming. So, no, I think if anything, I kind of would like certain aspects of science to slow down a little bit, just so I have more time to digest what's going on. If a tree falls in the forest near a mountain and no Fraser fans are here, does it still have a Lagrange point? Good question. Misa Likiu, what's the status of ice giant missions? No status. The closest now, nobody. There's hopefully a mission to Triton in the future, and the Chinese are planning a mission to Neptune, maybe. Jacob Soley. Since we can't see anything before the cosmic microwave background was emitted, how do we know that it was there 300 years? Since we can't see anything before the cosmic microwave background was emitted, how do we know what was there 300,000 years before that? How do we know there was any time at all? The cosmic microwave background, this is the first point in the universe when everything had cooled down to the point that light could finally escape, that the universe became transparent. And this incredible discovery was sort of made by accident, where astronomers had built this radio telescope and they were scanning the sky and they got this signal that they were detecting that matched predictions from other astronomers that if the universe worked the way that we thought it did, then you should see this hum, this background radiation. And the way this works really is that, back in the 1920s, Hubble discovered that galaxies are moving away from us in all directions, that the universe is expanding. But really, a better way to describe that is that the universe is becoming less dense over time. And so if you run the clock backwards, then those galaxies would be getting closer and closer to each other and closer and closer to each other. And eventually, you would get to this point where all of the matter in the universe was so close together that it would all be ionized. And then there would be this transition from when it was all ionized, completely opaque, to when it was transparent and light could finally escape. And that it should give off this very specific wavelength of light that astronomers were able to detect. And the cosmic microwave background is the most beautiful piece of evidence that we live in this expanding universe. But then you just take the numbers and just keep going. That if you know the expansion rate of the universe and you're able to measure it back in time, and you're able to measure it to this point when the universe was so dense that it was opaque and that it was all just ionized hydrogen and helium, then you can just keep running the clock backwards. You just imagine the universe a little more dense and a little more dense. And eventually you get to this point where the entire universe is like the density of a star. And you can calculate the amount of time that would take from when it was the density of a star to when it was the density when light could actually escape into the universe. And if you imagine that the universe was the density of the star, then you can calculate how long it was like the density of the interior, the core of the sun, right? And you say, oh, it was about that way for about a dozen minutes, about 12 minutes. And that it was able to turn hydrogen into helium during that time to create about the ratio of about, say, 75% hydrogen, 25% helium. And that's the ratio that we see of hydrogen to helium in the universe. So not only do we have that time when we're seeing this radiation, this first light from the universe, and then you do the math and you get back to this time when the universe was like the core of a star, you get those ratios, which is the second big pillar of evidence, was that, okay, yeah, it once spent time like the core of a star, then it spent time like the surface of a star, I guess. And you could just keep running the clock backwards. And then we know, okay, then there was a time when you actually didn't have atoms, you had the subatomic particles. And then you could just keep going. And you could find this time when the various forces merged together, and you had the electroweak force, and you had the merging with the strong force. People haven't been able to figure out how gravity fits into this. And you can just keep doing the math, and that takes you right to the moments after the Big Bang. And that's as far as we can go. That's as far as the math can take us. But, the CMB is just beautiful when you just think about what it's telling us. And it's just math. It's extrapolating what we see today, making predictions, seeing what you were hoping to see, and then continuing that process right to the Big Bang. Canadian Space Advocate. Do you think there's more room for science reporters or debunkers? I don't understand. Are you saying that is there more room for science reporters, or is there more room for pseudoscience debunkers, or is there more room for science debunkers? Um, I'm not sure how much science debunkers we require because, hopefully if it's science, it's not bunk. But you definitely want bad science debunkers. One of the problems that we have right now is that we've got the media landscape is fracturing. So in the olden days, when I started doing Universe Today, there were dedicated space journalists in a lot of the major media outlets. You had Miles O'Brien at CNN. You had people at Florida Today. You had people at MSNBC, Alan Boyle at MSNBC. You had a bunch of dedicated reporters at all of the big news outlets. And when you would go to the Kennedy Space Center to watch a space shuttle launch, there were trailers for each one of those outlets. There's a CBS trailer, and there's an NBC trailer, and there's an ABC trailer. And I walked past all of these trailers that were mostly empty when I was there last time. And then people started to cut away their ability to report on science. There was no longer a space reporter at these large media agencies. Maybe you just had a science reporter. And so the science reporter could tackle biology news, health news, and have to do some space news, but they're not going to have that same level of knowledge. And then you got even the science reporters were no longer necessary and were laid off. And so now you've got the weather reporter who's having to do some science news, or the environment reporter, or the health reporter is having to tackle some of this stuff as well. And so they're just not going to know. So I think, but at the same time, these big media agencies are running out of money. They're, unless you're the New York Times and a couple of other big agencies, they've got a business model that just isn't sort of carrying the day and helping them be able to increase the quality of their news reporting. And I think what you're seeing then is a big success in the smaller news agencies like Universe Today. What are we? We are me and maybe a dozen reporters who specialize in space and astronomy. And that's all we report on. It's all we know. And so we're able to specialize and stay current and up to date and make sure that our information is accurate. And I think there's still a ton of room at the bottom, not like bottom, like a ton of room like for the small guys. And so if you want to be a science reporter, you can do great science reporting, start a newsletter, be able to actually earn a living from that newsletter and just keep going, which is sort of like even a smaller version than what we do with Universe Today. So I think there is still a tremendous amount of opportunity for people who want to do this. And there's huge hunger for it. Like, remember that, everybody loves space. Everybody loves this stuff. And yet the quality of the reporting isn't able to keep up with the demand, the hunger. And when you look at these smaller folks that are heavily covering rocket news, just every single thing that SpaceX is doing, there's like 10 channels on YouTube that are like every tanker movement, every barge arrival, every bolt attached, they're all over it from the sky, from Boca Chica. It's kind of amazing how much, and that just sort of shows that the demand is there, but the supply isn't there in the way that it was before. So people have been able to fill this niche. So I think there's still huge opportunity for people to be science reporters. Whether you want to be a debunker, it just depends on your attitude. There's like, Professor Dave does a great job of debunking. Look at Simon Dan does a great job of debunking. Godless Engineer. There's a ton of channels that I think do a great job of debunking. Some are more in your face than others. And then you've got people like me who do the reporting side. And I think there's tons of room for that as well. So I would say there's tons of room for all of that and more. I just don't think that you can look to be part of a larger media institution in the way that you could in the past. You've kind of got to go your own way, and that requires a certain level of entrepreneurship. At the same time, that you are doing your reporting. Yeah, Eric Berger at Ars Technica. But like Ars Technica is owned by Condé Nast, and Condé Nast is a giant public company. And so, I mean, Eric Berger is, I think he's the best. Like if I would say the best space journalist working today, it's probably Eric Berger and Jeff Faust. They're the best. But both work for larger organizations, and who knows what the future holds as they downsize, as they have to deal with financial constraints. I mean, at least at Universe Today, we don't have any of that. We're not a public company. Universe Today ends when I die of old age, in a billion years in my robot body. Menelik Henry Dreyer. What other interests do you have outside of space science? So many. It's funny. When I started Universe Today, I was working for a web development agency in Vancouver, and I had a lot of crazy ideas about building websites. And I would sort of talk to my clients about these ideas, and they'd be like, I don't understand. I haven't seen any examples of this. Can you please sort of show me how this works? I'm like, okay, fine. I'm just going to do this myself. And so I built Universe Today as a chance to both explore one of my hobbies, which was space and astronomy, which I'd always been a fan of even as a little kid, but also to practice my theories about what it takes to run a website in this modern age, that they have to be updated on a regular basis, that there's got to be a certain amount of personality that comes through, that you want to offer people different ways to receive this information, that it's not about building the website, it's mostly about maintaining the website. But it was a fluke that the story was about, it was a fluke that the website was about Universe Today. It was a fluke that the website was about space. I happened to be reading The Case for Mars and Pale Blue Dot by Carl Sagan. I happened to be reading The Case for Mars by Robert Zubrin and Pale Blue Dot by Carl Sagan. And so I was sort of inspired by space at the time. I'm like, okay, space, that'll be the website, but it's just be a side project. Who cares? But pretty quickly I learned, no, this is all I want to do with the rest of my life is write about space and astronomy. Now I just have to figure out how to make a living from it. But I had tons of other hobbies. Like I could have, I was really into video games, and I think that would have worked just fine. I would have been a video game journalist instead of a space journalist. Mountain biking, hiking, living on Vancouver Island, cooking, science fiction, reading, traveling, any of those could have been what I ended up publishing. So, but yeah, I'd say like right now I'm super into, like restoration of the natural habitat. So where we live here on Vancouver Island, we've got a pretty big chunk of land, but it was forested. And so all of the trees were cut down, and now it's just a whole bunch of tightly packed Douglas fir trees planted a meter apart, and it's not healthy. And so I'm out there all the time with a chainsaw cutting them down and just imagining like, what would be cool if we opened up more area and I planted other stuff and I brought in native species and there's birds and ducks and all kinds of stuff. So I found snakes and lizards and newts and different kinds of plants, rare plants. So that's what I'm, I always ask people like, what are you obsessed with? That's what I'm obsessed with and have been for the last couple of years right now. And I'm sure, yeah, that would be someone asked me in another QA, like what, if you didn't do Universe Today, what would be your website? And it would, an alternate universe Fraser Cain, and it would be probably a website about, or video series about living on Vancouver Island and just like how amazing this place is. So and who knows, if I have time, I'll do that too. I don't have time. Uranus. This show is like ASMR to me, it helps me relax and fall asleep. That's weird to me. Um, I always think I'm so frenetic. People are always sort of surprised when they see me because you know, I'm tall, broad. They expect like a little guy who's very frenetic. Um, the Piper, I love Fraser Cain, but what are some other good YouTube channels? I hate the AI crap. So I've been sharing one new channel every week with a smaller creator, and I'm going to do that again shortly. So stay tuned. What time is it? 5:52. Okay, probably one more question. Rob Hawk, you seeing more ticks where you live? We have no ticks. We have some ticks, but very few ticks. I've never had a tick in my life. I'm sure now the ticks are descending on me, but I've never had a tick. Our dog had two. My wife had one. All right. Some mad random person. Are all the galaxies moving away at the same rate, or are some faster than others? So at the closest scale, the galaxies are moving in various random directions. So Andromeda is moving towards us. I think the Triangulum galaxy is moving roughly towards us. All the other galaxies in the local group are all kind of moving around each other. But outside of the local group of galaxies, the galaxies that are in the 10 million light years away range and beyond, they are moving away from us. And the farther the galaxy is, the faster that galaxy is moving away from us. And this was the amazing discovery that Edwin Hubble made back, a century ago, was as he measured the distance and the rate of movement of all of these galaxies around us, he found that they were, the farther the galaxy was, the faster it's moving away from us. Until at the farthest reaches, galaxies appear to be moving faster than the speed of light away from us in all directions. So right up close, it's kind of random just because we're all locked together in gravity. But beyond that, it's a very smooth relationship. The farther it is, the faster it's moving away from us. And yet, if you go anywhere in the universe, you'll see the exact same thing, that all the galaxies are moving away from you. How weird is that? Okay. Rutger von Odenhoven. How much dark matter is there in our solar system? It all depends on what dark matter is. So if you assume that dark matter is a particle that is evenly distributed across the entire dark matter halo, the total amount of dark matter that's in the solar system is a surprisingly small amount, probably about the mass of a small asteroid, so it has almost no effect if it's here in the solar system. But most of the area around the galaxy is not solar systems, it is the empty space. It is the interstellar space in 3 dimensions between star systems. And so that's how you get this thing that accounts for 10 times the mass of the matter that we can see, is the invisible mass of the dark matter. Goat Lord, how big does an object need to be to hold an atmosphere, or does it have to do with its magnetic field? I think we need to sort of ask ourselves, how big does an object have to be able to hold a atmosphere for a long time? So, for example, you have Mars, which is relatively small compared to the Earth. It's like a third the size, a tenth the mass. So it has much less gravity, and it is not able to hold on to its atmosphere. It doesn't have a magnetic field, so it's not able to redirect the solar wind particles. and it lost most of the mass of its atmosphere to space a long time ago. And then we look at another example of, say, Venus. Venus also does not have a magnetosphere, and yet obviously Venus has an incredibly thick atmosphere. It's much closer to the sun than the Earth is, and so it's able to, it's receiving a lot more radiation from the sun. It's getting hit by the solar wind a lot more strongly, and so, but it's able to hold on to its atmosphere. But all of the hydrogen was blown away from Venus's atmosphere. So the heavier carbon dioxide sticks around, but all of the water molecules were broken up by ultraviolet, and the hydrogen atoms were blasted away into space. And so without that protection, it still has an atmosphere, just a carbon dioxide atmosphere. But we could put an atmosphere at the moon that had the density of the Earth. It would just be be a lot smaller on the moon, and it would hold on to that atmosphere for about 10,000 years. And so you'd only need to replenish it once every 10,000 years. So it's really more of a question of time. How long do you want that atmosphere to remain? I always think it's such a cool idea that you could terraform the moon. Okay, so we've reached the end of the first hour, and so now I'm going to record all of the administration stuff, all of the stuff that sits around the question show, and then we will come back and we will do overtime. So go ahead and, go to the bathroom, grab a snack. It's going to take about 5 minutes before we get on to the overtime segment of this week's show. So you've been warned. Or watch it. All right. But then remember, there's a whole other hour. So don't go. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down in the YouTube comments, and I will gather a bunch of them up and I will answer them here. All right, let's get into the questions. Oh, right. I see this backwards. I don't know why. Okay. What is the biggest star in the universe? I don't understand the Fermi paradox. Can galaxies exchange stars? All right. What is the biggest star in the universe? How come I don't understand the Fermi paradox? And can stars swap between galaxies? All this and more in this week's question show. I'm sure you noticed the Star Trek planet name that appeared above my shoulder. This is a way for you to vote, for you to tell us what you thought was the best question, the best answer, the best hybrid question answer. And the winner this week was from Antonis Karpanos. Where should I send my scientific discovery to be checked or promoted, to be known to other scientists? So thank you, everybody who voted for that question. Now, we're going to put a different Star Trek planet name up above my shoulder for every question in this entire show. We're going to put the names down in the show notes so you've got a nice reference. And then at the end of the show, after you've watched the entire episode and you've really thought carefully about what was the good question, go ahead and put that Star Trek planet name down in the comments down below, and then I will gather them up and we will celebrate the next one next week. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: Igor Bizarny, Hoppy Rabbit, Avery Buell, Rusty, Matt McHugh, David McDonnell, Janice Smith, Ben Mills, Brett LaRue, Martin Trevino, Not Sure, Joker. Join the club at patreon.com/universetoday. All right, those are all the questions we got this week. Thank everyone who put your comments into the YouTube chat, as well as everybody who joined me for the live show. We do the show every Monday at 5 p.m. Pacific time. It is twice the length. It's like 2 hours long, and yet we edit it down painfully into the QA that you're watching right now. So if you want the full experience, come and join the live show. Monday, 5 p.m. I'll put a reminder here on the channel. Now, I'm going to continue my conversation. I'm going to continue directing you towards small channels that deserve your subscription. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Antonio Lofilara, David Gilton, Dougie Stewart, Dustin Cable, Jeremy Mattern, Jordan Young, Josh Schultz, Mark Anstis, Paul Rohrbach, Stephen Krasaki, Stephen Feiler-Munley, and Vlad Chiplin, who support us at the Master of the Universe level, and all of our other patrons. All your support means the universe to us. I don't know if the colors are going to change here, Chad. Let me just give you another one of these just to be safe. All right, so for the last couple of weeks, I have been directing you towards other channels that I think you should definitely check out. And I had a couple of people recommend this channel, and I really like it. So the channel is called Eager Space. And on Eager Space, they cover a lot of concepts in spaceflight. For example, what does it cost to hire an astronaut? Or, let me see. Yeah, all right. They cover a lot of interesting topics like the story of the Vulcan, or what does it take to cost it? They cover a bunch of concepts like what does it cost to hire an astronaut, or the story of the Vulcan, or what's going on with Starliner. So I think, a lot of channels are focused with laser rapt attention on every single thing that SpaceX does. But it is a big industry of spaceflight. There's a lot of other companies that are doing a lot of other interesting things, both currently as well as historically in the past. And it's great to see a channel that is considering all of this other stuff that has happened now and in the past, as well as sort of dealing with questions like, could the space shuttle have ever gone to the moon? So check out Eager Space, and definitely keep sending me your recommendations for small channels, less than 10,000 subscribers, that are doing a great job of talking about space and astronomy and other scientific concepts. All right, we'll see you next week. Okay. Beep. That's the sound my camera makes when I press the record button. QA 252. Good morning. Just got here in the usual 9 a.m. Did daylight savings time just end in Canada? End? Yeah. Daylight savings time just ended. I didn't even notice. Like all of the clocks that I interact with are now so automatic that I didn't even notice the daylight savings time had changed for like a day. Okay. All right, let me start the audio for the next part. Hello, patrons. This is the overtime audio that we recorded on Monday, March 11th, 2024, as part of QA 252. All right, enjoy this additional content. Robert Wallout, is it practical to put a telescope on the far side of the moon? I mean, is it ever practical to put something on the moon at all, or especially not the far side? Like, there's very little has ever been sent to the far side of the moon. But what is the value of the far side of the moon? The main value is that it is shielded from the electromagnetic radiation that is coming from Earth. And so if you put a radio telescope on the far side of the moon, it will be completely shadowed from all the chatty humans who are flying in their airplanes and sending their mobile signals into space and all of their broadcasts, it's finally quiet. You can finally hear your own thoughts, your own space radio thoughts. And so if we put a large radio telescope on the far side of the moon, then we can be sure that any radio transmissions that we're hearing from the universe are not coming from planet Earth. And there's been some really great ideas. I mean, if you build a radio telescope on the far side of the moon, you could potentially access the very specific wavelength of emissions that's given off by hydrogen shortly after the Big Bang. There is the potential to detect the interactions between exoplanets with magnetospheres and their stars as they have giant flares. Like, it's a twofer. You discover a planet. Also, you discover a planet with a magnetosphere, which is pretty cool. So most of the telescope proposals have suggested some version of a radio telescope. People say, oh, wouldn't it be super cool if you put just a telescope on the moon? And sure, I mean, it is effectively a space telescope, but it's a space telescope that you have to deal with hot and cold temperature changes as the moon goes through its day-night cycle. Getting stuff down to the surface of the moon is very complicated. And then you still have gravity. You have stupid gravity that is pulling down the various parts of your telescope with like 1/6 Earth's gravity, but still, it's not nothing. Now, there are a couple of upsides. Like, if you had a telescope on the moon and maybe you put it down at the South Pole, then you could leave it in eternal darkness and it could get very cold, and you could have an infrared telescope that would see the southern view of the sky. Like, it would be limited by what you could see because you're always pointing towards the south of the celestial sky. But the upside is that if we do have some future moon base research station, then you've got astronauts that can go over and they can turn the telescope off and on again if there's a problem. They can upgrade the hardware, they can diagnose it, they can construct bigger parts of the telescope. So I think in the short term, we're probably going to see a radio telescope on the far side of the moon. And then in the medium to long term, whenever we have a research station on the moon, we will probably then get a telescope, like a proper telescope built on the moon that will be built and maintained by astronauts. Whether it's on the near side or whether it's on the far side, doesn't really matter. Any research station will probably be on the near side of the moon just so it can have direct radio communications with Earth. Putting it on the far side puts people out of contact and, doesn't give you any real advantages. So, because, the moon goes around the Earth. So it's not like some part of the sky that you can't see, whether you're on the near side of the moon or whether you're on the far side of the moon. You're not in eternal shadow. You're not on the dark side of the moon. Lance Piles, can you explain how rockets start in 0G? If there's no gravity, how do you get the fuel to the bottom of the tank, the fuel inlets? I mean, this sounds like a Scott Manley question, but pressure. I mean, you maintain a certain amount of pressure inside the fuel tank that allows you to keep the pressure up so that when the rocket needs fuel, you're able to still supply fuel to the rocket. This is an issue that happened this is a potential issue when you think about liquid fuel rockets, methane rockets that are, all of the fuel is going, you want the fuel down at the bottom of the rocket so it can feed into the engine. And as you accelerate, then maybe in a different direction, then maybe the fuel is going to float away inside the rocket, away from the intakes of your actual nozzle. So there are a lot of concerns about how various rockets are going to work in zero gravity when you can't count on gravity pulling your fuel down. But again, this is outside of my knowledge base. That's a Scott Manley question. Biggles Tintin, would it be possible to have a camera on the surface of the moon focused on the Earth? Sure. But the moon is pretty far away from the Earth. I mean, the moon is 350 to 400,000 kilometers away from the Earth. And that's far. But there are, like, there's the Discover mission, which has a telescope pointing at Earth from the Earth Sun L1 Lagrange point that has a nice view of the Earth. But yeah, you could put a camera on this, a telescope on the moon pointing at the Earth. But like, if all you want is just like, hey, that's us, that's our planet right there in that picture, still, how cool is that? But scientifically speaking, you want things that are much closer, weather satellites, things in geostationary orbit. You want to get a lot closer to the Earth if you want to get science done looking at the Earth. But you could definitely put a camera on the moon and have it point at the Earth. Christopher Sturf. I know sound waves propagate to human ears via air molecules. What allows gravitational waves and radio waves to move through space? Well, this is one of the long-standing questions that scientists were really trying to figure out before Einstein came along. That when you have air moving through, or when you have sound waves, they're moving through the medium of air, that you have molecules that are bumping into other molecules. And when you have water in the ocean, you have water molecules that are bumping to other water molecules, and that gives you waves. And so once scientists discovered that light behaves like a wave as it moves through the vacuum of space, they assumed that there must be some kind of medium that light is moving through. And so they describe this as like the ether, I think. And it was accepted that that's how this worked. But there were ideas that were considered a long time ago. Like when you go back and think about what even Galileo had figured this out, that, you know, you thought about, like, if you were in a ship and you were moving on a perfectly flat, smooth ocean, you would not be able to tell that you were moving compared to if you were just stationary on Earth, that there was a certain amount of like relativity that you would experience. And so when people did experiments and they said, like, you know, if we're going to move light, if we're going to shine light in the universe, we should detect, you know, if we're moving, we know that the Earth is moving around the sun. We know that the sun is moving through the galaxy. We know that the galaxy is moving through the universe. There is a motion that the galaxy is making, and that when we shine light in various directions, it should change in its speed depending on its orientation to the direction that the Earth's true motion through the universe. And that's not what they found. They found that light moves in the same direction, same speed, no matter what direction that you send it. And so it really took Einstein to figure out, no, wait a minute, that it's the speed of light is constant, and that there is no absolute frame of reference, that everything is relative. Now, there are still people that wonder, is there some kind of medium? Is that space-time, some medium that light or gravitational waves are moving through? But you would need to explain how there's no preferred direction that these things move in compared to movement. There's a lot of things you would have to account for. And there's been no evidence that such a thing exists. So it appears that it is just the property of space itself that allows for the propagation of gravitational waves and photons, which radio waves are a type of photon. Michael McConnell, how do they measure magnetic fields at cosmic distances? So, yeah, you can't like hold a magnetometer up to a magnetic field that is around a galaxy that is several billion light years away. So how do you know? And so what they do is they detect the light that is coming from these galaxies, and there are certain wavelengths of radiation that are generated by magnetic fields interacting with matter. And so if you detect the presence of the radio emissions, so a good example is like we can detect the auroras coming from Jupiter. And that is because that particles from the sun are interacting with the magnetic field at Jupiter, and they're causing this auroral activity that is shining in various wavelengths. You can detect these emissions. That tells you that the magnetic field is there. Now, it can get even fancier than that. Astronomers can detect the polarization of the radiation that's coming from those distant objects, and the polarization gives more information into the strength of the magnetic fields and even shows you the alignment of the magnetic field. So if you see like this galaxy cluster, this gigantic galaxy cluster, and you can measure the presence of this radiation that's coming from this galaxy cluster, that tells you the strength of it. But then you can measure with the polarization the actual alignment of the magnetic fields around and in larger areas. And some amazing maps have been done of the Milky Way showing like the shapes of the magnetic fields in our vicinity in all directions, just by measuring the those radio emissions as well as the polarization data. The Mitchmeister, why don't we have underwater habitats to simulate a moon base or Mars colony? We actually do. NASA has a NASA underwater, I forget the name, base, Nemo. It's called the NASA Extreme Environment Mission Operations, and it is a underwater habitat in Florida. And so astronauts go to this station. They have to go into it. They have to sort of deal with the pressure difference, and then they live inside this habitat at the bottom of the ocean in Florida. What's the depth? I don't know what the depth is. And so it has been going since 2001. And the most recent one, I think, was 2019. So, yeah. And I think more of that kind of stuff would be great. Like, you'll know we're getting ready to live on the moon or get ready to live on Mars when there are a lot more very well done, realistic habitats. Now, there's a lot of ground-based ones that NASA runs an experiment every year where they lock a bunch of astronaut wannabes in a simulation in Hawaii on Mauna Kea. Oh, what's it called? Oh, I forget the name. Someone's gonna mention it. But they pretend like they're on Mars for like a year, and they have to deal with long communication timelines. They can't leave their base without being in a spacesuit. They have to deal with various resource constraints, bandwidth of being able to send information back and forth to Earth, and they have to also like live on limited resources and get on each other's nerves in a limited space. And then, of course, there are things like Biosphere 2, which was the simulation of a closed environment in Arizona, which, had its problems. And there's a much smaller version of that in China. They've had a closed environment where they had a team of 4 astronauts live in this closed environment for a year, where they were generating all their food and generating all their oxygen and living in this enclosed environment. So it's been done in bits and pieces, but I think that there is so much to be learned by going through the simulation process that we're not ready. That much more closed loop simulations have to be made, have to be done, have to be perfected before we can get close to saying, okay, we understand a lot of the variables on what it's going to take to live on a place like Mars or the moon for long periods of time. Now, you make up for it. Like, we know what it's like to live on the International Space Station. You just send more stuff, send more air, send more water, send more food, take away the poop, take away the garbage, and you can sort of deal with this. But for places that are really far away where it's just not feasible to send regular supplies, the moon, it's feasible, but Mars is not super feasible. You're going to send large supply drops, but a lot of the stuff that's done on a regular basis, they're going to have to handle it themselves. Cup of Dan, should we be worried about explosive satellite weapons? Yeah, I think so. Now, we've seen multiple tests from multiple countries of people showing that they can, with precision, destroy satellites and turn them into, from a functioning or a dead satellite, into a hail of metallic shrapnel that then endangers other spacecraft in the area. So we know that it's perfectly viable to pretty much destroy any satellite that they want. You know, if a nation wants to, they can, like, they all have airplanes ready to go with anti-satellite weapons, and whenever they want, they can take out satellites. You would just have to suffer the consequences, both the international community being grumpy about what you just did, as well as the consequences of increased space debris. So should we be worried? Yeah. I mean, like when somebody, has nothing else to lose and decides, well, I'm just going to take all my toys, I'm going to go home, then maybe they're going to consider destroying other people's satellites because they don't care anymore. That would suck. Dream, what are your thoughts on the Dragonfly mission? I like happy thoughts about the Dragonfly mission. I mean, Dragonfly, this is this mission to Titan that's going to send a nuclear RTG, a radioisotope thermoelectric generator, to Titan, and it's going to fly around. It's an octocopter, and it's going to fly around on Titan and examine different places, different spots, different terrain, sides of craters, look for how sand moves around on the surface of Titan, sand made of ice. Yeah, I'm incredibly excited. I mean, we learned from Ingenuity that it is feasible to send a rotorcraft to another planet. And Mars is almost the worst environment. Like, the moon would be worse. Rotorcraft won't work on the moon, but Mars is terrible. Mars has 1% the atmospheric density of Earth. It has 1/3 the surface gravity, and so if you fly, turn your rotors fast enough, it will function. But Titan, you've got an atmosphere that is denser than Earth. You've got surface gravity that is lower than Mars. You've got the absolute perfect place to send a rotor vehicle to make just tons of ground every day, go wherever you want. And it's powered by an RTG. This is the same kind of power system that's in Curiosity that launched in 2012. It's the same power system that's in Perseverance that's been there. It's the same power system that's in the Voyagers that have been going for 50 years now. And so in a perfect world, we could have a RTG, we could have a nuclear powered helicopter flying around on Titan for decades, exploring whatever we can imagine. Now, the big downside is there is no intention for it to go to the methane lakes, which are near the poles of Titan. It's going to be going closer to the equator. But I wonder, like, once they've completed their main assignment, are they just going to start flying north? We're not going to the methane lakes. We're just going north. And then after 10 years, do they arrive at the North Pole of Titan and explore those lakes? Yeah. I couldn't be more excited. Not only excited, like, I feel like I'm in a dream that this is a thing that's actually going to happen. I can't believe it. Ellen Gross, why the South Pole of the Moon? What about the North Pole? No craters? No, there are eternally shadowed craters at the North Pole as well. Moon. I think there's more at the South Pole, but I think there is. Yeah, so at the North Pole, there are permanently shadowed craters as well. One's called Etlinger. Is that right? Etlinger? So yes. Topical Tom Garcia, will you ever buy an electric mountain bike? So I bought an electric bike, but it's more of a road bike just because I do more mountain biking. But yes, I would like. I'm really addicted to my electric bike. I've recently figured out how to override its settings so that it has more power levels and it has a higher top speed, and that's made it even more fun to use. So before it only had 5 power levels, and now my bike has 9 power levels. But I did take it, like it could handle like really simple terrain. Like it could handle like a logging road, or it can handle some like a nice trail. But I was foolish to take it on a rougher mountain bike trail, and it just didn't work. So there's a totally different class of mountain bike, the electric mountain bikes for that. And I'm probably gonna have to do that. And I really should, because I really wrecked my hip flexors riding a mountain bike. Like I too much. I rode my mountain bike too much. A lot of going up hills, and I didn't stretch properly, and I didn't sort of go into it very carefully. I just went from not mountain biking a lot to mountain biking every day for 2-hour rides, and I trashed my hip flexors. So getting an electric bike is going to be the way, because like people with electric mountain bikes, I was raving to Pamela about this earlier today when we did astronomy cast. Like apparently people who ride electric bikes end up burning more calories than people who ride regular pedal bikes, because you want to spend more time on the bike because it takes the pain of going up hills away. Everything is the same, and it's a lot more fun to ride the bike. So if you're like worried, like, oh, I'm going to get soft riding an electric bike. No, you're going to ride that bike more than a non-electric bike. Church discography. When are you going to go back to the blue screen background? So I have a plan, which is, I mean, right now the weather is terrible, but once we hit springtime, summertime, I've got lots of room to play with in the forest. I've got places that I can put up various more permanent structures. And so I'm thinking I might build like a concrete desk in the forest, with a concrete chair so that it can handle going through the winters. And then I could set up my laptop and just use Wi-Fi and just beam it towards where I'm set up. And I could set up some lights for some fill lighting, and yet I would be in the forest. And so I've got a couple of places which I think I can set up to do that. So I did one video about a month ago where our power had gone out, and so I couldn't use my actual setup, and so I had to record outside where I could get some sunlight with Casey Dryer. And so I was sitting out on my patio. Unfortunately, the weather was really nice. And then for fun, I took my camera into the forest and I recorded the intro and the outro. So, but it's funny because it like generated a whole bunch of new, like, why are you on a green screen? I'm like, oh, so I might, who knows? I think I'll do more, this summertime and do some more shots and stuff outside. I mean, the problem is like, I'm interacting with this screen in front of me, the one that contains you. So, if I'm going to do a question show, or if I'm going to do Space Bites, like I could do Space Bites with a piece of paper. I think that would be no problem. Because I just, because I freestyle the whole episode just with a couple of notes. So I could probably do that outside. So who knows? Who knows? Yeah, my bear sidekick, coming back to the videos. Yeah, we see a lot of bears here on the property, for sure. So it's really just a matter of time. If I spend a lot of time outside, that a bear is going to wander through the field of view behind me. Pelican 666, do you ride the Whistler's mountain bike park? No, oh my God, this is going to be such a humble brag. The mountain biking on Vancouver Island is the best in the world. Like Whistler's great if you've got hundreds of dollars and you want to pay for a lift ticket to go up and ride those trails, it's great. They're amazing. But the riding that we have here on the island is world class. Like, it's hard to describe how nice the mountain bike riding is here on the island. Ferdinand, what would be more catastrophic to humanity? A Carrington-level solar flare or a chain reaction of satellite crashes? A Carrington-level solar flare would be worse because it would destroy ground infrastructure. It would destroy transformers. It would destroy computers, internet relays, solar farms, anything that's connected with wires to other things would be damaged. While a chain reaction of satellites crashing into each other, yeah, that would be a big problem, a very big problem. We would lose communication systems, we would lose weather satellites, we would lose a lot of stuff, Earth observation, science, things like that. But society would carry on. But if we actually had a Carrington-level solar flare or more hit the Earth, then vast swaths of Earth would be out of power and would take months to get everything back online. But don't make me think. Gah, that's a tough one. All right. Zach, what is dark matter made of? We don't know. No one has still figured out what dark matter is made of. We just know that it's there. We know how it clumps. We know what effect it has with its gravity. We know where it is. We know how much of it there is, but we don't know what it is. And that's going to take us a while to figure out. Mickey Finn, what sci-fi movies, TV do you recommend? I mean, I always go to the basics. Like, if you want TV shows, The Expanse and For All Mankind, I think, are two very realistic space TV series. Movies, The Martian is great. Interstellar was fine. But then if it's just like it doesn't matter whether it's realistic or not, I would say the best thing that I've watched on TV recently would be Love, Death, and Robots, which is a series of short shows on Netflix. They've got 3 seasons. Each season has 12 of these little, some of them are really short, just 5 minutes long. Some of them are more 15 minutes long. You'll snap them up in a night for each series, and they're so good. They are adaptations of science fiction short stories or just really, really cool ideas. And for each season, and they get better and better and better. The first season, I was like, this is great. Second season, oh, this is super good. And the third season, I was just entranced. I was so amazed at how good it was. So if I had one recommendation of a thing to watch, it would definitely be Love, Death, and Robots on Netflix. There's a lot of good stuff. Stephen Collins, if Universe Today stopped all articles on Lagrange points and Fermi paradox, would there be anything else to talk about? I don't think we spend a lot of time talking about the Lagrange points on Universe Today. We don't, it doesn't come up much in research. I mean, if I see a story, I'll definitely send it off to the writers because I think it's cool and it's got that Lagrange point thing. But the Fermi paradox, yeah, we report on that a lot. It's hard not to, I'm in control of Universe Today. I get to decide what stories we report on. And so anything that I feel makes any kind of meaningful progress on this philosophical question, I throw to the writers because I want to see someone report on it. And who knows if any of this is moving the needle, but it is definitely Universe Today is absolutely a reflection of my personality. All right, because the way the site works, that every day I go through all of the sources that are posting news stories, journals, conferences, press releases, research is being done at various universities, and then I winnow that down to, I don't know, 8 to 10 stories that I kick over to the writers. And then the writers will fall upon those stories like hungry dogs, and then they report on them. They're free to write whatever they want. They don't have to listen to me and get my suggestions, but it's so easy when Fraser delivers you this story in a nice tidy bow with a title and a description and I've gone and already gotten the paper from the author, and I've gotten quotes from them, and I just deliver it all nicely. And the writers, they often will pick up the stories that I recommend. And so now, like, this is something that's fairly recent, like probably in the last couple of years, that I've been a lot more intentional about how we pick stories on Universe Today, what the topics are. Like, every single title that you see on Universe Today, I'd say, okay, 90% of the titles that you see on Universe Today came from me. Right? I suggest the title to the writer as part of the package. And then the writer goes, ooh, I like that story. I like that idea. I'm going to report on that story. And like, this is like I'm living the dream, which is that I don't have to report on all these stories anymore. I find them, but then I kick them off to the writers, and the writers actually do the work. So why don't you hire scientists and publish papers? I can't afford to. Kidding me? The total budget of Universe Today would be less than the salary of one person at a major media company, right? Our entire annual revenue, all of the expenses that we have for the entire team, we are so close. We run so close to the bone. With absolutely minimal expenses. We couldn't hire scientists, publish research. That, unfortunately, that is not a business model that we could sustain. Now, a bunch of our writers are scientists. How many PhDs do we have in the team? 5? I think we have 5 PhDs, and then a bunch of master's degrees. Does anybody not have a degree? A couple of people don't have degrees. And, my degree's in computer science. So, but no, I can't imagine us doing our own research. That sounds expensive. Sean E. Yeah, a good scientist is like 150K plus full benefits. I'm sure a lot of scientists would love to earn 150K plus full benefits. So, yeah, like 2 of those would be our entire company. Curious Borg, I've seen the new Dune movie. Did you like it? I have not seen it yet. I am waiting for it to arrive on streaming. I'm a patient man. Canon right. Could we use gravitational waves to see inside a black hole? Unfortunately, no. There's no way that you can learn about what's inside the event horizon of a black hole from observing it from the outside. Now, maybe there's a way to do it with the holographic principle, but it's really tough to see it. Yeah, I don't know if anybody who's got any practical ideas on how to be able to see what's inside the event horizon of a black hole. Kai, in your opinion, what would be the coolest time of day to see the upcoming total solar eclipse? Which angle, position in the sky? I would not choose where I go for the coolest position for the eclipse. I would go for the place which I can get to and which gives the best chance of good weather. So where along the eclipse track can you go that has the highest chance of the best weather? And I think it's closer to the south, like Texas. Like, that's where we're going. Even though I'm Canadian, and even though the eclipse is going to pass through Canada, I'm going to Texas to see the eclipse because I think the weather is going to be better in April in Texas than it will be in Canada in April. So I think those are your first, second, and third priorities is weather, weather, weather. And even when you've picked your place, like, okay, I'm going to go to Texas, you got to stay mobile. You got to stay frosty. You got to say, okay, a couple of days before the eclipse, you're looking at the weather forecasts and you're saying, what places around me that I can reach within a couple of days of travel offer me the best chance of getting clear skies? And then you move. And then even on the day of the eclipse, you're like, well, how is the weather doing? You could be, and even an hour before, you might have to hop in your car and drive so that you're no longer covered by clouds. So you have that chance of seeing the eclipse. So, seeing it from a cool angle or position in the sky, unfortunately, like that would be neat to see it just as the sun is setting would be cool. But the thing that's most important is just you want the good weather to be able to actually see the eclipse. Stay mobile. You got to mine deep. I heard today that rocket exhaust is mostly water. I always understood that the space agency is emission intensive. Is that still accurate? It depends on the rocket. So the space shuttle was a hydrogen oxygen rocket. It used liquid hydrogen, liquid oxygen, mixed them together and got an enormous amount of thrust. And the byproduct of mixing liquid and oxygen is water. And so, yeah, the exhaust gases coming out of the space shuttle was water. Now, it's water vapor, and you're dumping water vapor into the atmosphere, which is a greenhouse gas. So you've got to sort of keep that in mind. But other rockets use things like kerosene. The Falcon 9 uses kerosene, like aircraft fuel. The Saturn V used kerosene. And then newer rockets use methane, natural gas. And so they are greenhouse gases. And like Henry Dyer, could you explain how you would terraform the moon? The idea that you could do that, it would last about 10,000 years, blew my mind. Yeah, you take a bunch of atmosphere and you put it on the moon. How do you do that? I don't know. That's like magic science fiction technology. I don't know. You set up big factories on the moon, you break apart moon rocks with solar energy, and you release the oxygen into the atmosphere so that it makes a thicker and thicker atmosphere. And maybe you bring in nitrogen from some external source, and you could try to mimic Earth's atmosphere at the moon. It's how you do that is the complicated part, which is why it hasn't been done yet. What time is it? Okay. Canned air. There you go. Moonwalker, when are we going to explore lava tubes on the moon? Good question. There are no concrete plans right now to explore lava tubes. There's been a few proposals that I've reported on. Missions. So there's a Chinese mission that was proposed a couple of years ago where they would land near a lava tube and then they would have a spacecraft fly around and do like a LiDAR map of the moon. There was an American mission that proposed something similar as well. There's been various missions proposing different ideas. One is that there's some lava tubes that are, the collapsed skylights, so you could go down into them. But there's also ones where, in theory, it's just like there's an exit to the lava tube and then there's just a big cave. And if you could find one of those, you could drive right into the lava tube. And so that would be a lot easier to get into and a lot safer. We're just so far away. Like step one, let's get some astronauts on the moon. Let's do some nice surveys of the moon at lower altitudes. Let's pick some lava tubes. Let's send some robots to try and explore the area around them and eventually start looking inside them. But There are no plans. Serious Kaylee, no RV rental or motel room in the path of the eclipse. Yeah, at this point, like every place to stay on the eclipse path has been sold. D-suits. What about the great news this week on the progress of the square kilometer array and maybe bad news for the U.S. telescopes? I didn't know about the news for the square kilometer array. Yeah, the bad news for the U.S. telescopes, it looks like the Americans are going to merge the 30-meter telescope and the Giant Magellan telescope together. Oh, the square kilometer array prototype gets first light? You have to tell me what the news is about the square kilometer array. But yeah, so it looks like because of funding problems, because of rights problems, being able to build the 30-meter telescope on Mauna Kea in Hawaii, that the U.S. is considering merging the Giant Magellan telescope and the 30-meter telescope into one telescope, and it'll probably be on the Grand Canary Islands. Maybe it's going to be built in the Southern Hemisphere. It really should be built in the Northern Hemisphere. Like, I think the Canary Islands is probably your best bet. If you want to not build it in Hawaii, then put it in the Canary Islands and have a 30-meter class. Because then you've got the extremely large telescope being built by the European Southern Observatory 2027, and it's going to be in Chile. So you want a nice big telescope in the Northern Hemisphere and a big telescope in the Southern Hemisphere. Whoa. Man. Why isn't this working? Sorry. So I'm having a problem with the Dougal. Anything left on your bucket list? Oh yeah. I mean, I've done all the highlights. I've seen an amazing aurora. I have seen a total solar eclipse, but a crappy total solar eclipse. There was a big cloud in front of it for most of the time. So I haven't seen a good total solar eclipse. I'm hoping to fix that this year. I've seen a rocket launch, but the rocket launch was the OSIRIS-REx, which was like a Delta 4. And I want to see like a super heavy. I want to see a space launch system. That would be cool. And then I want a comet. I want a giant, beautiful comet. I want a meteor storm. Now, obviously, those are bucket lists that I can't go and just, I have to wait for the universe to throw these things my way. But those are definitely things that I would love to be able to see. All right. Why isn't this working? There. Okay. A whole bunch more questions were hidden. John Gix, why is there no telescope in the Rockies? I don't know, but probably weather. So, like, for a telescope to work well, you want to have nice dry weather. And the Rockies, I don't think, are as dry as, say, the mountains around New Mexico. Bucko, is there a spot someone could see an eclipse at any time, like at a Lagrange point? I mean, there is a spot, yes. There's a spot in the sky that you could go where the moon is casting a shadow from the sun. And that if you went and put yourself into the exact spot, then you would see the moon pass directly in front of the sun. But you would have to have a rocket ship to be able to do it. Tommy Boy, how much information do other space agencies share, or do they keep some secrets for themselves? It depends on the space agency. So the European Space Agency is pretty good about sharing information publicly in sort of the same way that NASA does. They have a 1-year embargo on a bunch of their missions. So for example, when the Rosetta mission was receiving data from Comet 67P, a lot of the photos from the best instruments on Rosetta were embargoed, and so we had to get these crappy pictures coming from the nav cams and not the really nice pictures. Other agencies are okay. India's really good. China's pretty bad, but they're surprisingly good now, and do share more information than they used to. But they could go a long way. And like if you're listening, China, if you're listening, share your information. I think if you want to be respected around the world or be admired for having cool space missions and being the place where amazing technology is happening, share your photos, share the data, make it available to scientists, to the public, to be able to look through the stuff and find cool things. So, I know it's all state secrets, but really, is a rock on the moon a state secret? Share it. Astronomy 66. How long will astronauts be able to live on the moon before they take the same radiation dose as 6 months on the ISS? I don't remember the exact numbers, but being on the moon is 200 times more radiation dose than being on the surface of the Earth. So if you're just out on the surface of the moon, you would receive a lethal dose of radiation over the course of a year. And then I think it's and then people on the International Space Station receive like 10 times as much radiation as you do on the surface of the Earth. So it's kind of like from the Earth to the space station is 10 times the radiation, and then from the space station to the moon is another 10 times in radiation. And sort of one of the things that's really interesting is that that the radiation dose that astronauts are going to receive going to, say, Mars, or even doing a long duration mission at the Lunar Gateway, is going to exceed the just mandated guidelines that astronauts can receive. There's no way that you can send astronauts to Mars and they don't receive way more radiation than they should. And so they're just going to have to be fine with that. They're going to have to break the rules to send astronauts to Mars. They have to sign a form that says, yes, I know I'm going to receive more than the allowable limit of radiation on this mission, and I will probably get cancer, and it's probably going to kill me, but I'm willing to do it. David P., what do you think about the subjects discussed at the SOL Standard Conference? I don't know what that is. I don't know what that is. Wait, what kinds of games do you play? Any online multiplayer ones that we could play alongside you? Could we join your Destiny Fire team? So I used to play Destiny until I just got bored of Destiny. Like, it was just the same thing, very shallow. Like, maybe Destiny 2 is a lot better, but what do I play right now? Like, right now, I am playing Terra Invicta, which is a strategy game where you're trying to defend Earth against an alien invasion, but various factions on Earth are trying to stop you or help the aliens or try to create panic or fear or try to just escape Earth. And it's sort of a cool idea. It's made by the same people that made if you ever played XCOM, there was a mod called the Long War that sort of made the game a lot longer and a lot more strategic. I like strategy games. RimWorld, Europa Universalis, Project Zomboid I've played a lot of. Stellaris I've played a lot of. So no, you probably won't be on my Destiny Fire team. And like, I'm not a Twitch streamer. I played a ton of Path of Exile, like a regrettable amount of Path of Exile. And like for me, because I spend so much time in front of the camera, I spend so much time sort of in public. Games are my way to unwind and not have any external pressure, because like if you're playing a game for an audience, you have to remember that you're performing. Like, you're not just playing the game. And like, I will play a game of RimWorld at regular speed. I won't speed up the game at all, and it's excruciating, but it allows me to sort of deal with everything that's coming at me and micromanage my base. And I'm sure anyone who's watching me would just be like, this is so boring. I'm not trying to create a performance. So, I've thought about streaming, playing games at various times, but that tank, the express my, like perform in public bucket is emptied by doing the live shows on, for the QA, as well as all of the other live streams, all the interviews that I do, the Space Bites, all of that. I can't imagine wanting to spend more time in front of the camera. I am baffled by Twitch, actually, just like, to be honest. I am completely befuddled how people will make that a career, because it just seems exhausting. You are enslaved to the audience. Like, I have a really good time doing these shows every Monday for 2 hours. And then at the end of those 2 hours, I'm just like, oh God, that is so tiring. I can't imagine that people like, and maybe, when I do these shows, they're a lot more intense, and who knows, I'm going to probably, we might do like a subathon where I try to encourage more of you to join my Patreon, and maybe I'll stick around, and every time a person joins the Patreon, I'll stick around for an extra 5 minutes or 10 minutes or whatever. But, we'll see how long that lasts. But yeah, I find this whole process quite, exhausting. Like, I'm definitely worn out by the time the show is done. Although the shows get longer, and we do, like, when I do the patron question show, it's like 3.5 hours long, and I'm still able to sort of I'm definitely losing my concentration by the end of that. So, and so I just, like, I don't understand how people can spend that much time in front of a camera, entertaining an audience, and it be ephemeral. Like, it's just entirely in real time that you're just interacting with this audience. And then the second that you have to go grab a bite or go to the bathroom, they go away, and there's nothing. You have nothing that remains from show to show. I would much rather work on building a space media company that retains an audience between shows, and I just get to show up and bring in new people into what I'm doing. So, but what Twitch taught me, I think, is that some people have a bottomless capacity for media. That we always ask ourselves, like, oh, is this too much? Like, if we do a 3-hour episode where we rank the Fermi paradox, or I do a Fermi paradox iceberg episode, is that too much? If we do a 2-hour long James Webb Space Telescope Year 2 summary, is that too much? And then I look over at Twitch And I see people doing 12-hour live streams. And I'm like, no, it's not too much. Like if people can stream 60 hours a week, we can provide 8 hours a week of content. All right. I think we've reached the end of the episode, reached the 2-hour mark. So I think it's time, and I am exhausted. So I'm going to wrap things up. So thank you, everybody, for joining me tonight. A huge, huge thank you to our moderators. Thanks to Zapfan and John Suffel for grabbing those questions and putting them into the database. Boy, I really couldn't do this without you. I really appreciate it. Thank you so much. What's coming up? So today I interviewed Thomas Zurbuchen, he was the director of the science policy at NASA from 2016 to 2022. He oversaw James Webb, the final parts of James Webb there for the launch. He helped drive the Ingenuity helicopter, a lot of the stuff that happened with Perseverance. Just an amazing guy to talk to. And I only had an hour, but it was such a cool interview. And that's going to come out in a couple of days. I think you'll really enjoy that one. We did an interview today, which I hope you watched because it was so good, about collecting samples from Enceladus and firing tardigrades with a gun at 1,000 kilometers per second. All right. Thanks, everybody. And I will see you next week.